Hi, I'm Kara O'Brien. Today, we are going to discuss Best Management Practices, or BMPs, and how to best maintain them. We will identify different types and parts of BMPs, discuss common maintenance problems and solutions for local government staff, landscapers, and homeowners. We will discuss landscaping a site with a BMP, the role of vegetation, and discuss LID practices. What are stormwater best management practices and low-impact developments? And why is it important for contractors and local government staff to understand stormwater practice maintenance? The EPA defines stormwater BMP as a technique, measure, or structural control that is used for a given set of conditions to manage the quantity and improve the quality of stormwater runoff in the most cost-effective manner. Low-impact development is an approach to land development that works with nature to manage stormwater as close to its source as possible. LID employs principles such as preserving and recreating natural landscape features, minimizing hard surfaces that increase stormwater runoff to create functional and appealing site drainage that treats stormwater as a resource rather than a waste product. Low-impact development practices include bioretention, rain gardens, permeable pavement, infiltration practices, vegetative conveyance, downspout disconnection, soil amendments, and many others. A car requires regular upkeep to make sure it is running smoothly. This calls for a knowledgeable mechanic. The same can be said for stormwater BMPs. Regular maintenance keeps them operating at an optimal level. So it is important for landscape contractors and local government staff to be up to date on sound operation of these practices. The Center for Watershed Protection's Sadie Drescher recently visited Ted Scott of Stormwater Maintenance LLC, who discussed basic bioretention function and maintenance.
We're here with an expert, Ted Scott, to help us with some maintenance issues.
I'm Ted Scott, the founder, executive vice president, and co-owner of Stormwater Maintenance LLC.
So what are some of the major components of a bioretention and some of the problems you would expect to see, Ted?
Bioretention facilities are vegetated landscape practices that also treat stormwater. These practices look very similar to normal landscape practices you might see, except they have some fundamental differences. The facilities are usually concave, or they're basins, so they're lower below the parking lot or the land around them, where traditionally landscaped islands or landscape practices are usually higher than the surrounding land. They collect the water to filter the water, remove the urban pollutants, and then to discharge the water through an underdrain system. So below the mulch on a bioretention facility is somewhere between 2 and 4 feet of very sandy soil media. This is the filtering media. This is what filters the stormwater. Plants assist with the stabilization of the bioretention facility and also aid in pollutant removal through biouptake. Below the sandy soil media are quite often a gravel and perforated PVC pipe underdrain system. So the water filters through the soil media into the underdrain system and goes into receiving waters as clean water.
One of the reasons for this bioretention and other BMPs that we're going to talk about, like permeable pavement or soil amendments, is to improve the water quality as well as reduce the runoff from the site. Basically, these are there because of policies and regulations in the Chesapeake Bay region. So we're going to see more and more of these BMPs.
That's right. Traditional stormwater management facilities are larger basins, usually covered with turf grass. Most often are hidden away in the back of a site at the low point, behind buildings or behind parking lots. These types of practices that are being designed today are much smaller. They are integrated into the sites, and they're designed to do more than one thing. So they may be aesthetic, they may be landscaping along with treating stormwater. They're not so obvious.
Ted, it is important to use a checklist to document and evaluate each site's condition during the maintenance visit. Can you explain the type of checklists needed?
Maintenance of stormwater facilities is something that does not require detailed checklists. Checklists that are shorter and more to the point and are written in plain English is something that's very important. The key components can be identified by following the water. How that water gets into the facility is an important thing to look at because that's where the water and the sediments, trash, and debris are entering the facility. The next step is the soil media. How is that soil media performing? Is the vegetation that's planted in that soil media surviving well? Is the soil media dewatering? Dewatering is one of the most important aspects of evaluating any type of stormwater management facility. Whether or not it is dewatering per the design is critical. If there's evidence of standing water beyond 72 hours, then there may be a problem with that soil media's performance. Lastly is the overflow. Most of these facilities, if not all, will have some type of overflow, and that may be a catch basin, a storm drain inlet, PVC pipe, something to handle storms that are larger than what the facility was designed for. All three of these components should be on a checklist that you're using to document and evaluate the condition of the facility.
Here are the major maintenance issues: inflow, outflow, dewatering or clogging, vegetation, sediment, erosion, trash, flow path problems, BMP not right for the site, structural failure, ownership, long, cumbersome checklists. Many of today's LID strategies use specialized soil, sand, and gravel layers in addition to the plants to filter pollutants and discharge clean water from the practice. It is important that landscape contractors, local government staff, and homeowners know how these practices are intended to work and how to maintain them so that they continue to function as designed. Why don't you and Sadie head out and see what practice maintenance issues you encounter?
Here we go.
We're here today on this lovely rainy day to visit a bioretention and look at some of the maintenance issues. I noticed some sediment around the inflow here at this bioretention and some of the urban pollutants like water bottles. But what are some of the other problems here in the bioretention that you guys are going to fix?
We've got erosion at the inflows that we're going to fix. We've identified the soil media may be potentially clogged because we've got some indications of algae in the bottom of it. That indicates that the soil media itself may not be dewatering as designed. We've got some weeds in it that we're going to be pulling, removing some sediment, augmenting with a little bit of mulch for this facility today.
Pine bark mulch can float away and clog the outlet structures. To avoid this, use triple shredded mulch.
Can you guys talk a little bit about the slopes?
We've got a slope that's a bit too steep, so we're going to be using some riprap to make a very small retaining wall to be able to eliminate that overly steep slope and resolve the issue of the erosion.
Bob, talk a little bit about some of the major pieces of the vegetation here and some of the issues with stormwater maintenance.
Well, looking at the bioretention from a landscaper's perspective, the plant material, the mulch, the weeds, they're all things you're going to find in a typical normal landscape bed environment. However, your weed management is different. It is an aquatic environment. You can't use the same herbicides and pesticides as you would in a normal landscaping bed. You're going to go through, you're going to do a spring pruning, you're going to do a fall pruning. There is a mulching process to the bioretention as well. It does involve raking it up, getting the old mulch out, putting the new down.
What a landscaper does not want to do is put too much mulch in. You do not want to end up with 6 inches of mulch in these things. The old mulch really should be removed if at all possible. And then when new mulch is put in, maintaining the original design, which is usually between 2 to 3 inches of mulch depth.
A common problem with these practices is that these maintenance tasks are neglected and the practices become choked with undesirable vegetation and are more difficult to maintain in the future. Ted and his team did a great job. They identified problems like erosion and slope issues, sediment clogging the soil media, trash, and the need to weed, prune plants, and remulch. And they got the job done. Just look, before and after. The water level decreased during this maintenance visit. But what about other problems that might be encountered? Let's return to Ted as he describes 2 different BMPs, their issues, and the necessary corrective measures.
Here we're at a bioretention facility that got some problems, we'll say. And it's important to identify what the problems are when you see them in the field. Some of these problems were driven by the design.
Maintenance personnel may need to consult with the jurisdiction, property owner, and/or the design engineer if significant structural maintenance is required.
What needs to happen here is some more significant one-time remediation that includes something to deal with the grade change, so maybe a low retaining wall or something along those lines.
The maintenance at this bigger bioretention today involves raking. Raking is a routine maintenance practice that will loosen and smooth the soil. This allows the practice to continue filtering water. However, Ted's team has seen a variety of maintenance problems at this site in the past.
This is a bioretention facility that could have been a large detention facility. The ground cover is only mulch, and the flow paths are evident through the mulch. We just recently had a rainfall event here. You can see where the water was going and how it's pushing the mulch around. And it's a very interesting study on what not to do with a bioretention facility. We were called in to deal with perceived flooding problems on the site. When we arrived at the site the following year, we got a call that it was another flooding problem at the site. We were wondering what could possibly be going on. We came back out to the site and saw that the landscape contractor had imported a lot of mulch and filled all the facilities with mulch once again.
Bioretention, wet ponds, and dry ponds are just a few types of BMPs. Bioretention is a common LID, and there are many others. Next, we discussed permeable pavement with Gail England of Arlington, Virginia.
I'm Gail England, a stormwater specialist with Arlington County Department of Environmental Services. We encourage a lot of permeable pavements here in Arlington. We're an urban environment with a lot of hard surfaces. What you need to know is, first of all, what kind of pavement it is. Permeable asphalt, permeable concrete, or permeable pavers. Permeable pavers have a separation that is filled with stone. So you need to vacuum out the debris that's in there and reinstall the stone. Permeable concrete and permeable asphalt, you just vacuum and remove the debris that's clogging it. Maintenance in general is just think ahead of what you're dealing with, what type of BMP you're working around. Oftentimes there are drawings associated with this. If you're dealing with a permeable surfaces, don't blow things into it. Don't store mulch, sand, or other debris on top of it. That just leads to clogging, and it's problematic.
We recently spoke with several local government officials about their BMP maintenance experiences.
Forest Heights is a small town, and with some funding from the Chesapeake Bay Trust and some funding from the National Fish and Wildlife, we have a working demonstration site. And that demonstration site has 7 rain gardens. Some of the questions that I get is, do you know the difference between one of our plants and what is our actual weed? How does the rain barrel work? How the extra water is hooked up to water hoses, and we utilize that to maintain our conservation landscaping or to water our rain gardens. We can have our rain gardens taken care of, and we can continue to do the work of making sure that our water is being recharged into the earth.
We have 11 of these retention systems in our town right now. My town employee crew, they handle the weeding of them, cleaning of them, but twice a year we bring in a professional firm to make sure all of the dead grasses, there's new mulch, new native grasses are planted, new bushes if necessary, but it's not a big problem because we're keeping on top of it. My men have been instructed to make sure that they do check these out, especially after heavy rains when it brings down everything down the street, leaves and trash. That's generally the maintenance that we have to do other than weeding.
In this stormwater practice maintenance video, we learned how to properly maintain BMPs and especially LID practices. Understand the common maintenance problems and solutions. Maintain plants and control weeds. Document the maintenance at each site using a checklist. And report major problems. To learn more about stormwater practice maintenance and other strategies we can use to protect and promote healthy neighborhoods and cleaner water, visit the Center for Watershed Protection website and sign up for our educational webcasts. Also, see companion resources such as the Chesapeake Stormwater Network and the key maintenance resources in your local area. Please share this with your friends and colleagues on Facebook and Twitter.